Guys, Dr. Naim just sent a new assignment calculus for us.
What kind of assignment?
Oh, basically, this assignment, we have to tell about arithmetic series. In this assignment, we have to present about arithmetic sequence, arithmetic series, and also the application of both arithmetic.
Today, our topic is arithmetic series, total production output with steady increase. In real life, many factory or company increase their production by a fixed amount each period. For example, a factory might produce 100 units on the first day, then increase production by 10 units every day. This type of situation form an arithmetic sequence when we want to find the total production over a period of time. Add all the terms together. This total is called arithmetic series. In this presentation, we will explain how arithmetic series help us to calculate the production output and why this concept is useful in real-life production planning.
Okay, firstly, we'll talk about the arithmetic sequence. An arithmetic sequence is a sequence of numbers where the difference between the consecutive terms is constant. So we have given the formula an equals to a plus n minus 1 times d. The an is the nth term, a is the first term, d will be the common difference, and n is the position of that term. So the nth term tells us that the value of any specific term in the sequence without writing out all the terms. We just apply the formula. So the sequence will look like a plus d, a plus 2d, a plus 3d, and so on.
Okay, so after knowing the n term of the arithmetic series, now we can find the sum of an arithmetic series, which means the total of all of their terms together. So the formula for an arithmetic series is given by Sn equal to n over 2 times a1 plus n. An is the last term of that series. But if the series diverges, we can use another formula, which is Sn equal to n over 2 times 2a plus n minus 1d. So this way we don't need to know the last term.
See, there's so many rice nowadays. Did you know the monthly total production of rice increases steadily?
But on what proof? So here is the graph of rice total production in Sabah. Let's turn this into a simpler form, which is of course a bar chart. As you guys know, in an arithmetic sequence, each value increased by a fixed amount. Look at this chart. The increase of rice production from one month to the next month is almost same, which form an arithmetic sequence. So basically, the idea is that the rice production is increased steadily on each month. Wait guys, but what if the factory wants to know the total production after those several months, not just the output of each month?
Good question. So, if a factory wants to know the total production after several months, we use arithmetic series. Instead of adding each month manually, the arithmetic series formula helps us calculate the total efficiently. In short, arithmetic series help us determine the total output over time. To relate this graph, a real-life example of the crops in Sabah, the common difference D is the daily NDVI or the slope of the line. If the crops grow at a relatively steady rate each day, the amount of greenness added daily is roughly constant. That is why the daily NDVI is the common difference. The sum of the series would be y-axis. This would mean if A1 is the NDVI on day 1, A2 on day 2, and so on. The x-axis, which show time in month, is the position of the term n. So, for an example, April would be N1, May would be N2, and so on.
But, does this series converge? To converge means the sum approach a finite value as time goes on. In this case, production of rice keep increasing by a fixed amount every month. So, when we keep adding the production output, the total production keep growing without limit. That means the arithmetic series do not converge, it diverge. In real life, this makes sense. As long as the factory keep producing, the total production will continue to increase.
So, in conclusion, arithmetic sequences and series are very useful in factories because they help to manage production growth.
Yes, this helps the manager to predict the future output accurately. By using arithmetic series, factories can know the total production over time, which helps with planning materials, labor, and also costs.
So, sequence and series make factory operations more efficient and
well planned.
that's all.
Bye.